Alright, my pizza lovers, this is Unit 1, Section 1.2, Math 1033C, and we're learning how to solve graphically. These are the steps. A graph should be made for both sides of the expression by setting y equal to each side, and by drawing the appropriate graph, which we have pre-drawn. Step 2, determine where the two graphs are equal for the same value of the variable. This will be the intersection point of the two graphs. There is a side note. If only one expression has a variable, then you make a graph for that side of the equation and find where the output is equal to the constant on the other side. And here's your equation. Now, since we're going to follow the steps, 1/2 x minus 3 equals -1. We're looking for the x value of a point which has the output value. And since our output value is -1, that will be the output. And to find the output, you have to draw a horizontal line across the graph, which we have not done yet. You have to draw the line through the graph. This marker is kind of bad. Hope you can see that. Following along with step 2, which is determining where the two graphs are equal for the same value of the variable. To find that point of intersection and identify the x value of the intersection point, seeing the intersects occur at x equals 4, which is right here. The horizontal line is going through -1 and through 4, which that will be your solution to the problem. And again, this is Unit 1, Section 1.2, and this is Professor Philly.
Next, we're going to learn what a formula is. A formula contains more than one variable in an equation. Formulas can be solved for a chosen variable using the same steps as equations, but the chosen variable must be isolated on one side of the equation with all the other variables and constants on the other. For example, let's solve 3x plus 5y equals 7 for y. First, what we're going to do is we're going to subtract 3x from both sides. So here we have 3x plus 5y minus 3x equals 7 minus 3x. After that, we're going to divide both sides by 5. So here we have 5y divided by 5. That cancels out, and we have y by itself on the left side. That's going to equal to 7 minus 3x over 5. And what we're left with is the solution. Y equals 7 over 5 minus 3 over 5x.
Hey guys, so we're going to be talking about interval notation and linear equations, or linear inequations. First, with interval notation, let's lay down the rules. Interval notation is a set of consistence of all real numbers between a and b. Now, there's brackets and there's parentheses. Brackets are closed intervals that include the endpoints. Notice I said include. For parentheses, it's going to be the opposite. They're going to be open interval and they exclude the endpoints. And then we have the infinity interval. And here goes some examples. But first I want to break down, before we get to linear equations, you have the less than, the greater than, and then we have less than or equal to. Then we have more than or equal to. And these are going to be important on whether or not you know which is going to be an open or closed interval. And when you write the equation or the answers to your problems, you want to start with the smallest to the left and the largest to the right. Here goes some examples. How are they written? -1 is less than or greater or less than or equal to x. X is less than or equal to 4. And how that is written is with a bracket, -1, comma, 4. And we have problem 2. X is greater than 9, which will equal parentheses 9 minus infinity. Notice that we used the brackets on number, or example 1, and parentheses on example 2, because this is the closed interval and this is the open. And since infinity is forever, that is the largest number, so it goes to the right. Alright class, this is Professor Philly. Welcome to linear inequalities. Now, if both sides of the inequality are multiplied or divided by a negative number, inequalities must be reversed. Now, solving linear inequalities is solved like any other equations, except when they're multiplied or divided by a negative number again, they must be reversed. For example, this problem, -2x plus 5 is greater than -9. Since we're solving it like any other equation, we would have to minus 5 from both sides. After we minus 5 from both sides, we get -2x is greater than -14. In the end, you must watch the signs because there are two negatives. Now, after we do that, we divide both sides by 2 to get the variable by itself. Now, before we move on, you see that we're dividing it by both sides. This gets canceled out. And since, again, this is a negative, which means multiplied or divided by a negative number, the inequality must be reversed. So since this is greater than, we change it to less than. Now, class, since these two cancel out and it's a negative, the inequality must be reversed. So x is less than 7 because you're simplifying the problem.
Next, we're going to solve the inequality numerically. Our solution will be a set of real numbers. First, we're going to find the input where the inequality is equal, and then determine which set of numbers, less or greater than the number, and solve the inequality. For example, if we're solving 0.5 times 3x minus 1 is less than 4, it's asking us to indicate on the table where we found our solution. If we pull up the table on our graphing calculator and enter 0.5 times 3x minus 1 in the y1 value, we're going to pull up this graph. First, we're going to determine where the output is equal to 4. So if we look on our graph, the output, we have 4, we have 3. This is where you're going to indicate it on for your solution. And the solution will become x is less than 3, or if we're doing it in an interval notation, it's going to be parentheses, open, negative infinity to the left, and 3 to the right, with another open parentheses on the right. Next, we're going to solve inequalities graphically. The solution is going to be a set of real numbers like before. we're going to find the point of intersection and identify the input value of the intersection point. Where it's greater than, it's going to be above. Where it's less than, below. Next, we're going to identify the solutions. In this example, we're going to solve 3x plus 1 is greater than or equal to 7. Here's our graph below. And it's graphing y is equal to 3x plus 1, and also this line represents the 7. Now, we're going to need to identify where y equals 3x plus 1 is greater than 7. This is where the intersection is, and that is at 2. So, it occurs for all the values to the right of x equals 2, or x is greater than or equal to 2, or if we want to put it in interval notation, we have a bracket, which means it's closed, 2 to the left, and going to infinity on the right with an open parentheses.
This is Professor Philly. And we're back at it again at compound inequalities. Now, there's only really 2 steps to this, technically 3. Now, involving compound inequalities involves 2 inequality symbols. The other step is isolating the variable in the center and performing all the operations. For example, here is the problem. 4 is less than 3x plus 7, which is less than 22. Now, since there's 3 separate parts, and the variable in the center, right here, which is technically 7, but the variable is the 3x. Now, we have to solve it like any other equation, which is minusing 3x from all 3 parts. So that will give you 4 minus 7 is less than 3x plus 7 minus 7. This is less than 22 minus 7. Now, 4 minus 7 equals negative 3. Make sure you don't get confused by the signs. 3x plus 7 minus 7. Since this is a negative and a positive, it cancels out. And that equals 3x. 22 minus 7 equals 15. Lastly, you just want to bring your signs down. And since it is not a negative, or it's not being multiplied or divided, the signs do not need to be reversed. To finish the equation, you have to divide 3 by all 3 parts to get the variable x by itself. So we have negative 3 divided by 3 equals negative 1. Then we have 3x divided by 3, which cancels out and leaves you with x. 15 divided by 3 equals 5. And again, we just bring the signs down. And this will be your answer. Negative 1 is less than x, which is less than 5. To write this in interval notation form, the answer will be negative 1 and 5. And it'll be parentheses, which is open, because it excludes the variable, or the endpoint.